Okay, this is Paul Geyer, and I will be the presenter today for this PDH source webinar, Ethical Issues from the Kansas City Hyatt Hotel Collapse. First, a couple of housekeeping items. The way the webinars move forward here is I press on with the presentation for 50 minutes, and then we take a 10-minute break so people can check their emails and do things like that. Come back, do another 50 minutes, 10 minutes, 50 minutes, 10 minutes. Keep going through that cycle. Now, this is, of course, is just a 2 PDH or 2-hour webinar, so we'll only go through that cycle 2 times. This is, of course, an interactive webinar, and questions and comments are welcome and encouraged. We've got 2 ways to communicate. One is you can just speak right up on the audio stream and I'll respond. The other is the little chat box where you can type in a question or comment, and I'll try to keep an eye on that as we go along and respond. Occasionally, audio difficulties may pop up on the audio stream, feedback, echoes, things like that. And if that should occur, I may need to mute one or more of your audio streams to get rid of that annoyance. But in which case you would just have the chat box to communicate with. However, everything sounds good now, and so my guess would be that we won't have any anyone having to be muted. You may be interested in getting a copy of these PowerPoints just for your future interest. And I believe you can get a copy of them from PDH Source. So just go to their website, log into your account, follow the instructions, and that you should be able to then download a copy of them. Okay, here we go. Ethical issues from the Kansas City Hyatt Hotel collapse. And here we go. Well, this is what we're talking about. And it's an incident that occurred in July of 1981. So quite a few years ago, obviously, but still quite relevant to what we do in our profession today. At the time, it was characterized as the most disastrous structural engineering failure in US history. And some might say, well, what about the World Trade Center incident? And the issue there, though, is that the World Trade Center was never designed to resist having an airplane fly into it or into them. And so that really wasn't a structural engineering failure. So I think this incident, this Hyatt Hotel incident, continues to this day to be the most disastrous structural engineering failure in US history. Now, what happened is that 2 interior walkways in the atrium lobby of this hotel collapsed, and this happened shortly after the construction of the hotel was completed. And this was in Kansas City, Missouri, not Kansas City, Kansas. And there was a resulting loss of 114 lives and injuries to 200 others. And that's the incident. Now here, just by way of introduction, a little bit about me. Let's see, I want to play with my controls here for a minute. And by way of introduction, this is a little bit about me and what I've been doing for the last few decades. For 35 years, I was what I characterize as a straight ahead designer, cranking out drawings and specs for the construction of buildings in a fairly broad spectrum of infrastructure features. And for 17 years, that was as an employee with a large public agency, the state of California. I resigned from the state then, and in order to start my own architectural engineering firm, which I managed for another 18 years. And then at that point, why I had an opportunity to do something that I had always had an interest in. And that was, I was in a principal staff advisor position to the California legislature in advising the legislators on infrastructure and capital outlay issues. I got registered in a few different things along the way, but I'm basically a mechanical engineer. That's my degree and my first registration. Um, but although this is certainly a structural engineering issue that we're talking about today, even a mechanical engineer can understand what the ethical issues were. So that's what I've been doing. Now here's kind of how I'll be chopping up the presentation, the chapters in the book, if you will. I'm going to talk quite a bit about the history of the project, how it came into being, because as I think you will see as we move forward, that's the manner in which the project came into being and was managed is what drove the ethical failure and resulted in this tragic incident. So I'll be talking about the history of the project. Then we'll look at the actual structural failure. What is it that broke? And we'll take a look at that, and it's pretty easy to see what the failure was. We'll see that when we get into it. And then the third thing is the what I characterize as the post-mortem, or the finger pointing that goes on, went on after this incident, and goes on, of course, anytime there is a serious incident like this. And so the post-mortem, were there ethical failures, or was there an ethical failure in the post-mortem, the finger pointing? Some of the questions that will come up, and we'll look at: was the disaster preventable? And I think the answer there clearly is yes, it was preventable. Were the post-mortem conclusions appropriate? In my view, no, they were not. And in my view, it was during the post-mortem that the ethical failure came up. Were the actions of the profession appropriate? This is more of the finger pointing by professional organizations like ASCE, NSPE, et cetera, et cetera. Would the conclusions be different if the failure occurred today? No, if the same ethical failures occurred today, the conclusions would be the same. Now, obviously, with an ethical issues webinar like this, there's a lot of room for differences of opinion, and there may be those who have opinions that differ from mine, and that's fine. But let's see, I'm making a note here to myself. And then finally, how do we prevent similar incidents from occurring in the future? So those are some questions we'll try to provide some answers to. And again, I emphasize that there's room for differences of opinion in a webinar like this. And what you're hearing, obviously, is my views. So here's what we're talking about. This is where the incident took place, Kansas City, Missouri, downtown. And this is the structure that we're talking about, the Hyatt Regency Hotel in Kansas City. And it architecturally, it consisted of sort of three modules. There was the tower part, high rise. This is where the sleeping rooms in the hotel were located. And then there was a kind of a mini convention center or a number of meeting rooms in a lower rise module. And in between the two, the tower and the meeting rooms module, was the lobby of the hotel. And it was an atrium type lobby. Big high ceiling, a lot of open space, very common architectural approach back in those days, 70s, 80s, into the 90s. So the three modules, the sleeping room, high rise tower, the mini convention center or function block, and then in the middle, the atrium lobby. Now, this is a picture of the atrium lobby today, as it exists today. So you see big high ceiling, a lot of open space, a very trendy architectural statement back in that day and age. It was kind of, or an early advocate of it was an architect from, I believe it was Atlanta, Georgia, John Portman. And he designed a number of hotels, as I understand things, for the Hyatt Hotel Company. And you can today, if you go into a number of Hyatt hotels that were built back in that era, you'll see these high atrium lobbies where it was a gathering place for guests to have a drink, chat, so on and so forth. So this is what the atrium lobby looks like today. And here is another view of the atrium lobby today. Now, this configuration for this hotel, though, had a difficult design challenge to deal with. And it, with this, the way it came up, or what it was this hotel was really intended as a convention type hotel. And so people would be sleeping in the high rise tower in their rooms, but their meetings that they were there to attend would be taking place over in the function block, or the mini convention center. And so a circulation issue uh, became apparent early on. And that is that people who would be sleeping in the high-rise tower, in order to get to their meetings, they would have to take an elevator down to the first floor, walk across the first floor lobby, rather large open space as you saw, and then take another elevator up vertically in the uh, convention center part to their meeting rooms on, say, the third floor or fourth floor of the convention block. And then the reverse, after the meetings were over, the attendees would need to take an elevator down in the convention center block, walk across the lobby, get on another elevator, and take that elevator up to their rooms. So that there was a lot of walking that was called for. Well, a solution was developed in the design of this hotel that involved the construction of walkways at the second, third, and fourth floor levels. And these walkways were suspended by hanger rods from the ceiling structure at the fourth floor level in the atrium lobby. And so a person in a sleeping room could just take an elevator down to, say, the third floor level and walk across this walkway across the atrium lobby and get right to their meeting room on the third floor. So this took care of the too much walking issue. And here is a cross section of the solution that was arrived at, cross section through the atrium lobby. And you see these aerial walkways at the second, third, and fourth floor levels. The walkways at the second and fourth floor level were on top of each other. And the one at the third floor level was offset. So this was the design for the atrium lobby. This is just a picture of the framing plan for these walkways. Structural steel members that supported the deck that the people walked on, and there were cross beams as you see here. So pretty straightforward. Now, but this again, this whole structure is suspended by hanger rods from the ceiling structure at the fourth floor level above the atrium lobby. So, and then the load is transferred from the hanger rods to the structure, and then it winds its way around and gets down to the foundation. This is a picture of the atrium lobby. the day that it collapsed, or the day shortly after it collapsed. And you see the debris on the first floor. And you see one of the walkways is remaining in place. That's the one at the third floor level. You see the walkway at the fourth floor level has collapsed, and it collapsed straight down on top of the walkway at the second floor level, and then the two of them crashed down to the first floor level of the lobby. So this is the picture after the collapse that we're talking about. Now, let's talk about how this project came into being, the history of it, and pay particular attention to the number of actors, if you will, who had a part in this project. And it all began in 1976. The civic and commercial interests in Kansas City wanted to get a convention hotel constructed in their downtown area. A common civic interest in those days, and continuing to today. And but hotels are kind of a difficult project to make work economically. And so frequently what civic and commercial interests in a city that wanted to get a convention center hotel developed needed to do was to find an investor who had a lot of money, who would put up the money to build the hotel. The well-known hotel companies, Sheraton, Hilton, et cetera, many years before, got out of the business of building hotels and owning hotels, and they just turned themselves into operating companies. So you have the civic and commercial interests in a city. They find somebody with a lot of money, or an entity with a lot of money, that's willing to be the owner of the hotel and put up the money to get it built. And this is a challenging undertaking in any city, continuing till today. And so the civic and commercial interests in Kansas City looked around, and it happened that a well-known large national company, the Hallmark Card Company, was headquartered and is headquartered in Kansas City. And the Hall family that owns, if you will, the Hallmark Card Company were longtime civic leaders in Kansas City, and they had a lot of money. So the civic and commercial interests turned to the Hall family and Hallmark Card Company to see if they would be willing to be the financial angel that would put up the money and be the owner of the hotel. And the Hall family and the Hallmark Card Company was open to this suggestion. And so they established a corporation called the Crown Center Corporation, which the Hallmark Card Company controlled. And this Crown Center Corporation was to be the the owner of the hotel. And this was agreed to. And then the Crown Center Corporation, or the Hallmark Card Company, went to the Hyatt Hotel organization to operate the hotel, and entered into an agreement: when we get this hotel built, you will operate the hotel. And the Hyatt Hotel Company was brought on at the very beginning of this planning and design and construction process. And it's not clear from the record exactly what the Hyatt Hotel Company was doing during the planning and design phase, but it is probably pretty likely that they were involved in some review and or approval type of role during the planning and design phase, simply because they understand how a hotel needs to be configured and what it needs to have in it, so that they can do a good, efficient job of managing the hotel once it gets built. So we've got kind of three entities here that have walked on stage, if you will, in this play. There's the Hallmark Card Company, the Crown Center Corporation, and the Hyatt Hotels Company. Crown, the owner of the building, hired a master designer, an architect, and of course, architects are the master designers who know everything that needs to be known about designing buildings. And the architect that Crown hired was an entity called PBNDML, Architects Planners Incorporated. So Crown hired PBNDML as the prime contractor responsible for all aspects of the building design. PBDML's fee was $1,650,000. That's approximately 6.1 million in 2009 dollars, the last time I did the arithmetic. It would probably be pretty close to $10 million in today's dollars. And I point to these fees so you can get a feel for where the money was going in this project. And was it the money going in the right places or place to get the building designed and constructed safely and efficiently? So another actor, if you will, walks on stage, the master designer, the architect, PBNDML. PBNDML then hired as a subcontractor an entity called Gillum Colaco as quote, consulting structural engineer. GCI, Gillum Colaco Incorporated. GCI's fee was $247,000, approximately 921,000 in 2009, probably be about a million two or something like that in today's dollars. So another entity is walking on stage, Gillum Colaco, a quote, consulting structural engineer. Gillum Colaco, GCI, subcontracted the structural engineering work to an affiliated firm, Jack D. Gillum and Associates, for an unknown fee, at least unknown to me. Gillum prepared approximately 60 drawings for the structural design of the project. Keep that number in mind because that will be relevant. So Jack D. Gillum prepared about 60 drawings for the structural design. And of course, there were all sorts of other subcontractors to PBNDML, mechanical engineers, electrical engineers, fire protection engineers, civil engineers, et cetera, et cetera, et cetera. So a lot of people from various organizations are getting involved in this project. And this is what in my view is where the project began to go off the rails. A large number of people, entities, business entities with different motivations and sometimes conflicting motivations. As an example, anytime any entity is working in a subcontract role to a design master contractor or construction contractor, there are inherent economic conflicts. The master architect wants to pay as little as possible for the structural engineering work. The structural engineering firm wants to make a fair fee and be able to devote the amount of time to the project that is appropriate. So a lot of people are getting involved in this project. Now, hang on just a second while I check something here on my controls. Okay, so design of the project begins in 1976. There was another actor that came on stage, an entity called Concordia Project Management, which was hired as construction manager, apparently by the Crown Corporation. So another entity characterized as a construction manager. What exactly was Concordia Project Management doing? Not crystal clear from the record. The design of the project was completed in 1978, and it was put out for competitive bidding. And of course, anytime you have a competitive bidding taking place for construction work, the job's going to go to the lowest bidder. Therefore, the lowest bidder is probably going to be under a lot of economic pressure to get the job done and not go broke. Not to put too fine a spin on it. So the drawings and specs were completed in 78, competitively bid, and an entity called Eldridge Construction was awarded the construction contract for the project on the basis of competitive bidding. Now, of course, in any construction project like this, there are all sorts of subcontractors that are needed on the project. The general contractor is really a manager, and the actual work out there, as we know, on the job is being done by the subcontractors. So one of these many subcontractors was an entity called Havens Steel. Let's see, let me get my slides back where they need to be. Okay, Havens Steel Company was awarded a subcontract to fabricate and erect the structural steel for the project. Haven's contract was for $390,000, approximately 1.5 million in 2009 dollars, probably be around pretty close to 2 million in today's dollars. And as is the way the industry goes, Havens obtained this subcontract based on competitive bidding to Eldridge in competition with other structural steel fabrication and erection subcontractors. A point that the record does reflect is that Havens held itself out to its customers as providing engineering services as well as fabrication and erection services. So Havens is holding itself out as being qualified to provide the engineering work on the structure. Havens, the subcontractor, then subcontracted the structural steel detailing work to an entity called WRW, which was a company that had an experienced registered professional engineer as a principal. And WRW prepared about 40 structural drawings for design of the project. So Jack D. Gillum prepared about 60, WRW prepared about 40. So it's quite clear that the structure was not designed by one entity in one location. The structural design work was split between Gillum and WRW. And this is whether it's a good idea is certainly debatable, but it's the way the industry has developed here in the US, where the nominal structural engineer on a project essentially sizes the beams and the columns and that sort of thing. But then the steel erection subcontractor designs the connections. So the structural design work clearly was done in two different places. Crown, the owner of the building, hired an inspection firm, H&R Inspection General Testing, to assure the quality of the construction work and its conformance with the working drawings and specifications. General Testing had a registered professional engineer in its employ. Another actor walks on stage. H&R Inspection General Testing. So the stage is getting a little crowded here. Another couple of data points that are interesting. One is that on 3 occasions, Gillum requested funding to have a full-time project quality control representative, an inspector on the job site. A very prudent and desirable situation with substantive complex projects to have a full-time inspector on the job. But Gillum's request for funding for a full-time inspector were turned down 3 times. Who turned them down? Was it the master designer, the architect, PBNDML, who didn't want to pay for a full-time inspector on the project. Was it turned down by the construction management firm, whatever they were doing on the project? Was it turned down by Crown? And the record is not clear. But Gillum said, I want to have a full-time inspector out there, and his requests for funding were denied by somebody in this crowd. Another data point that is interesting is that the specifications for the project were prepared by the master designer, PBNDML, not by Gillum, the nominal consulting structural engineer. The record indicates that, quote, structural aspects of the specifications were reviewed and commented upon by Gillum, but the specifications for the structural work were prepared not by the structural engineer, the nominal structural engineer Gillum, but by the master architect, PBNDML. So a third data point is that while the building was under construction, on October 14th, 1979, the building is under construction, the portion of the atrium ceiling structure collapsed. And this collapse occurred on a weekend, and fortunately, and there were no workmen or people in the building, so there were no fatalities or injuries. But a portion of a structure collapsing should be an awfully big wake-up call for everyone involved in a project. That clearly indicates something is not going smoothly, correctly with the management of this project. It's something wrong. So the structure collapses while, or a portion of it, the ceiling structure collapses while it's under construction. Crown, the owner, retained an independent structural engineering firm, an entity called Seiden Page, to investigate the cause of the roof collapse. Seiden Page identified the cause of the collapse. Design changes were made by Gillum, and that was the end of Seiden Page's involvement in the project. Seiden Page was not retained to investigate the overall adequacy of the design. And I would suggest that when you have a part of your ceiling structure collapse during construction, it's probably a very prudent thing to do to have the entire design reviewed, because something's not working right on this project. But Seiden Page was not retained to do a comprehensive structural evaluation. Was this due to these economic pressures that we see all over the place in projects like this? Did PBNDML not want to pay Seiden Page to do a comprehensive structural review? Did the construction management company not want to pay Seiden Page to do this extra work? Did Crown not want to pay Sidon Page to do this work was what was the Hyatt Hotel Company doing in all of this. The Hyatt Hotel Company probably had substantial control over the budget on the project. So you've got all of these people participating in this project. They've got different motivations. Essentially, a construction project like this, a design and construction project like this, is pushing and shoving contest with to see who can make the most money out of the project, candidly. Then the failure, the structural failure, the path to the structural failure was set. The construction of the building was completed, and the hotel opened for business in July of 1980. In July of 1981, there was apparently a kind of a rowdy social function going on in the hotel. There were 1,500 people present at this social function, which was what it was a weekly dance contest held in the atrium lobby, sponsored by a radio station, I believe. And there were at this event large numbers of people in the atrium lobby dancing and socializing on the ground floor of the atrium lobby, and also on the 3 suspended aerial walkways. The structural failure occurred at this event. 2 of the 3 suspended walkways that traversed from one side to the other side of the atrium lobby. The walkways that failed were at the 2nd and 4th floor level, and they were directly aligned. The failure began at the 4th floor walkway, which then crashed down onto the 2nd floor walkway, and both of them collapsed. And the 3rd floor walkway, being offset, was not involved in this failure. As previously indicated, there were 114 people killed and 200 injured. And this is what the scene looked like after the failure. You get a scale of these structural elements because you've got people in the picture, so you can see that these were big structural elements. This photo shows the 3rd floor walkway remaining in place, suspended by the hanger rods from the ceiling structure at the 4th floor level. Down below at the 1st floor level is the debris from the collapse. Here you see the failed suspension rods at the 2nd and 4th floor levels. Here is the 3rd floor walkway remaining in place. More pictures to show the magnitude of the debris, that these were not small structural elements. Okay, I'm now looking at my clock, and it's 10 minutes before the hour. So let's take our 10-minute break now, and we'll come back on the hour and pick up here. And we'll look at the actual structural failure, what it is that failed. And then we'll look at the post-mortem. How was the collapse investigated and what conclusions were reached and what finger pointing went on. So we come back at just about on the hour and we'll pick up here. So I'll see you all in 10 minutes. Okay, this is Paul Geyer and I'm back. Okay, so what went wrong? I mean, from a strict structural standpoint. Um, and initially there were, theories thrown out. One that was kind of popular, if you will, was that all of these people that were engaged in this dance contest um, were dancing around on these walkways, and their activity resulted in a forcing function, if you will, that was the same as the natural frequency of the walkways and the structure. And as a result, resonance was set up, and the walkways, were brought down by this resonance. This theory was discarded pretty expeditiously, because for resonance, you need to have a forcing function that is basically pretty narrow. And that's just not the nature of resonance, or of for a forcing function, because it's random. So that resonance was discarded fairly early on. As the investigation went on, it was determined that the failure was due to a change made by the steel detailer, WRW, a subcontractor to Havens, which in turn was a subcontractor to Eldridge. And the change was to the connections between the suspension rods and the walkway deck structures. So this was a change that was made by WRW, by the steel detailer, at the direction of Havens. And why did WRW, at Havens' instigation, make this change? Havens told WRW, this aspect of the design is going to be too difficult and too expensive to accomplish, so change it. So economic pressures, save money on this project. So the let's see, let me get my slides going here. The design that Gillum provided for the suspension rods and their connection to the walkway structures was, from a constructability standpoint, was poor, no question about it. It required suspension rods approximately 40 feet in length, and that the rods would have to be threaded for approximately 30 feet of their length in order to install the nut on the rod that supported the fourth floor walkway. You'll see this in these pictures shortly here. And this is, from a constructability standpoint, was certainly not a good idea. So Havens directed WRW to change that detail on the fabrication drawings. And this was the Gillham's design for the connection of the suspension rods to the deck structure at the fourth floor level. Suspension rod comes down from the ceiling of the fourth floor, the structure, and it passes continuously through a hole drilled in the cross beams, which were a box beam that was fabricated by welding two C channels together. So the suspension rod is continuous from the fourth floor ceiling level down to the fourth floor walkway deck structure level, where the detail is what you see here. Then the suspension rod continues continuously down to the second floor level, and the connection is similar at the second floor walkway level. So a very long rod, one that would require threading of the lower 30 feet or so in order to put in place the nut that you see in this sketch, on which the fourth floor walkway deck structure rests. So the load from the fourth floor walkway deck is transferred directly to the continuous rod. So this was Gillham's design. Havens took a look at this, went ballistic. This isn't funny, but went ballistic and said to WRW, change that connection detail. So at Havens' direction, WRW changed the connection detail at the fourth floor walkway level to what you see here. A rod continues down from the fourth floor ceiling structure to the fourth floor walkway structure, and is connected as you see here. And it's the load is transferred from the fourth floor walkway deck to the nut on that rod. But then to eliminate the need for the 40-foot long rod and the 30 feet of threading, a second rod was what was the solution that Havens and WRW made. And so a second rod is offset from the first rod, and that second rod then drops down to the second floor walkway level, and the second floor walkway is connected to that second rod. So this is the detail that Havens and WRW made to Gillham's design. So Gillham's design, the load on the nut at the fourth floor walkway was whatever it was, P. With Havens WRW's design, however, The load on the nut at the fourth floor walkway is now P at 2P, and the load from the second floor walkway is transferred to this second hanger rod, which then transfers the load through the box beam to the second rod, which then continues up and is attached to the ceiling structure at the fourth floor level. So this was a change that Havens WRW made to Gillum's design. Now there was another consideration here, that Gillum's original design sized the suspension rods such that they were strong enough to support only 60% of the imposed load based on code allowable stresses. This also was a mistake by Gillum, but not a fatal mistake, not a mistake that caused the failure, for the reason that code stresses are around a third to a half of yield. So even though Gillum's rods were not capable of keeping the loads beneath those allowed by the code, it was not a fatal mistake. So here is a picture of failure. What happened at the fourth floor level? The rod pulled out. More close-ups, details here. So now the finger pointing begins. Havens said that they notified Gillum of the change by telephone. Gillum denies having received any such telephone call. Havens submitted over 40 steel fabrication drawings to Gillum for review. Included on one of these drawings was the fatal change. Gillum reviewed and returned the drawings stamped, quote, reviewed only for conformance with the design concept and for compliance with the information given in the contract documents, end quote. A typical stamping for shop drawings. Havens proceeded to fabricate and erect the structural steel for the project in accordance with the drawings that it had prepared, Havens and WRW. A data point here in the finger pointing phase is that several participants in the design construction process purported to have told Gillum of concerns that they had about the safety of the proposed change, including in those who alleged that they had told Gillum of their concerns, were the construction detailer, WRW, the steel fabricator, Havens, the master designer architect, PB&EML, and a technician of some sort. Now, is there anything interesting about these allegations? Well, what is interesting is that Havens and WRW made this change, and they then, according to them, they called Gillum and said, hey, we just made a change to your design, but we don't think it was safe. I mean, that's just nonsensical. So this was an incident of that had great national notoriety. It was front page stuff in newspapers all over the country. Very high profile. So the those who were leading the show decided that the design needed to be reviewed by an entity of the highest degree of technical competence. And it was determined that that entity was what at that point in time was known as the National Bureau of Standards. And today it's the National Institute of Standards and Technology. And so the National Bureau of Standards was the lead agency in the technical investigation following the collapse. And by the way, a number of years ago, I had some involvement with NIST, the National Institute of Standards and Technology, and I was very impressed by their campus. It's like a college campus devoted entirely to technical issues of one sort or another. So the lead in the technical review of the design was the National Bureau of Standards. And it concluded in its report that the design change, which led to the failure at the box beam nut suspension rod connection, was contributed, it was due to that design change, which WRW Havens made to Gillum's design. It was, according to the National Bureau of Standards, it was contributed to by the failure to design the suspension rods to code approved stresses. Yes, that is true. But the stresses were still below yield. So this was not a fatal mistake by Gillum. Also, it was the National Bureau of Standards said that it was contributed to by the failure to provide redundant suspension rods. Well, this is a little tiny bit disingenuous. And yes, of course, if there were redundant suspension rods, it may not have failed, but redundant suspension rods by definition are redundant. So it's kind of taking an unjustified poke at Gillum. The National Bureau of Standards specifically concluded in its report that, quote, under the original hanger rod arrangement, continuous rod, the box beam hanger rod connections as shown on the contract drawings would have had the capacity to resist the loads estimated to have been acting at the time of collapse, period, end of quotes. And that is clearly critically important and clearly indicates that the failure was not due to Gillum's design. It was due to the change that Havens and WRW made. And here is the executive summary, a cut from the executive summary of the National Bureau of Standards report, which says just what we got through saying. Under the original hanger rod arrangement, continuous rod, the box beam hanger rod connection as shown on the contract drawings would have had the capacity to resist the loads estimated to have been acting at the time of collapse. End of story. So these additional slides here are just a little bit of historical discussion of why the practice in structural engineering developed over time, whereby the structural design is not all done by the structural engineer. The structural engineer, probably due to economic pressures, wanted to get rid of the workload of designing the connections. And so the nominal structural engineer sizes the beams and the columns and so on and so forth. But then the design of the connections of the beams to the columns and to the decks is left to the construction fabricator and steel detailer. So this is, we're not gonna, you, you get a copy of these PowerPoints, this will be discussed. So finger pointing, now the National Bureau of Standards has clearly concluded that the failure was not due to Gillam's design, but rather was due to the changed design that was made on the shop drawings by Havens and WRW. But the Missouri Registration Board, at the time of this incident, registration boards all over the country were running around in circles saying, oh my goodness, we could never have this happen in our state, and we need to assure the public in our state that we're right on top of this thing and that we're going to really hold our registered professional engineers to a high standard. And for what it's worth, back at that point in time, I happened to be in close contact with the California Registration Board. And I know they were, like I say, running around in circles. We've got to find someone here in California that we can convict of some kind of negligence, so that the public will have confidence in our government agency. And this was what the Missouri Board was doing also. And so the Missouri Registration Board said that Gillam and another professional engineer in his employ were guilty of gross negligence, misconduct, and unprofessional conduct in the practice of engineering, even though the National Bureau of Standards clearly concluded in its report that the failure was not due to Gillam's design, but was due to the change that Havens WRW made to Gillam's design. Nevertheless, the Missouri Registration Board wanted to nail somebody's hide to the wall, and it was going to be Gillam and this other engineer in his office. And they were convicted of gross negligence, misconduct, unprofessional conduct in the practice of engineering. Their registrations were jerked, and their careers essentially were ruined. Obviously, there were great damages, property damages, and of course the many lives that were lost. And as the way things go so often in situations like this, who ends up paying for the damages is the insurance companies. And apparently the Crown Center Corporation and the Hallmark card people had plenty of insurance coverage. Now, here is, I want to have you take a look at the National Bureau of Standards report, the technical evaluation of the failure. And this is their report, and it is 377 pages. And the Missouri Registration Board had this report right in front of them. And it said very clearly what you just saw in the executive summary, that if Havens WRW had not made the change to Gillum's design, it would not have failed, period, end of story. But the Missouri Registration Board just ignored the report and the conclusions of the National Bureau of Standards. This, in my view, is where the ethical failure took place in this incident. It was at the Missouri Registration Board where, in my view, irresponsible in the extreme to have completely ignored the National Bureau of Standards report. The Missouri Registration Board, though, said, well, we're going to conduct our investigation. And so they hired a bunch of lawyers to conduct a, quote, investigation. And these lawyers came up with 457 pages of transcript of the administrative hearing conducted by the Missouri Engineering Registration Board. And this is exactly what you would expect lawyers would come up with. 457 pages of lawyers asking questions. You know, did you do this? Did you do that? Et cetera, et cetera. And of course, everybody is going to be responding, no, I didn't have anything to do with this. This was Gillum's fault, not mine. And of course, Gillum had the big target. And everybody involved in this project was shooting arrows at him. And the investigation conducted by the Missouri Engineering Registration Board wasn't by any stretch of the imagination an engineering investigation like the National Bureau of Standards investigation was. It was nothing but a recording of lawyers spending hours and hours and hours and running up huge bills to just ask questions. Well, did you do this? Did you do that? Yeah, and so on and so forth. So again, it is my view that the ethical failure in this incident was the Missouri Registration Board. Okay, this is one that I received from an engineer in Kansas City who had some direct involvement. I I've got some leaf blowers outside my office window here. I hope you can still hear okay. They should be out of the way in a couple minutes. I'm going to try and get rid of them. Hey, okay, it looks like they're going away. Um, anyway, this slide that you're looking at here, I got an email a number of years ago from an engineer in Kansas City who had some direct involvement in the review of the project. And let's see. I'm looking at your comment. Gillum did not properly review the shop drawings. Yes, that is the case, and that was a an error. Uh, Certainly on Gillum's part in reviewing the shop drawings. But again, his failure to catch the change was sloppy work, but it is not what caused the failure. The failure was the change that Havens WRW made. Let's see. Says, did I see on page 42, I think that the summary of the NBS report included a bullet point. As originally designed, the continuous rod would not have met the Kansas City building. Yeah, I think that is a legitimate point. So and really that's what I touched on earlier when I said that the NBS pointed out that the rods in Gillum's design would only was the size was only satisfactory for 60% of the code requirements, the Kansas City building code, or using. So yes, that was sloppy work on the part of Gillum. It was a mistake, but it did not cause the incident, the accident, the fatalities. So anyway, um, well, and getting back to this email that I got, there was an issue with the welding as well of the box beam, the two channels together, but it's not really relevant. Now let's see. Well, it has certainly. Okay, and who's this? Jared. Yeah, my audio is breaking up. That was the leaf blowers that were outside my window, but they're gone now. So hopefully my audio should be okay now. Um, yes, Gillum did not do a thorough job of reviewing the shop drawings, but there's a difference, I feel, between unethical conduct and sloppy work. And everybody knows that reviewing shop drawings is usually done by lower level people in an engineering office, junior engineers, or even engineering technicians. And the typical rubber stamp that is used by all engineers in commenting on shop drawings is that the shop drawings have been reviewed for conformance with the general uh, uh, design concept, but that the subcontractor, the steel detailer who made the change, is responsible for the adequacy of the design. Um, so uh, well, that's how I see it, Gary. Okay, let me see if I got any more comments here now. Okay. Okay, let's press on here. So Gillum's license was registration was canceled, and in essence, his career was, I guess it was not completely damaged because he apparently, according to the record, uh, was practicing in California under a California registration. Um, um, so let me, now, was this disaster preventable? Clearly, yes. If Havens WRW had properly designed the changed detail. And also if the improperly changed detail had been noted and corrected by Gillum. Yes, that is true also. Other actions that may have prevented the collapse were if Gillum had provided redundant suspension rods, and if Gillum had sized the suspension rods in accordance with code approved stresses. All correct statements. No question about it. No question that Gillum was guilty of some sloppy work in checking not or failing to catch the change on the shop drawings. But bear in mind that WRW had a registered professional engineer on that I think owned the firm, and also that the Havens held itself out in its advertising as being capable of not only fabricating and erecting steel, but of doing the engineering of steel structures. So, so the postmortem placed all of the blame on Gillum. But what is the responsibility of Havens, which held itself out to its customers as providing engineering services? What's the responsibility of WRW, which designed the change under the direction of the registered professional engineer that owned the company or was on its staff? What's the responsibility of the master designer, PBNDML, which held itself out to its customers as being the master designer responsible for all aspects of design? What's the responsibility of Eldridge, which held itself out as responsible for all construction, including that of its subcontractors, Havens and WRW. What's the responsibility of the owner, Crown, which did not provide additional structural engineering funding for structural engineering review by Side and Page after the earlier atrium collapse and after Gillum had recommended and requested funding 3 times for a full-time inspector at the job site. That we need to recognize the economic pressures that everyone in a project are under. And the engineering profession immediately, for public relations purposes, decided that it needed to show that it was being vigilant in protecting the public. NSPE created something called Canon number 1. Both it and ASCE came out with pronouncements that the structural engineer is responsible for all matters of safety as far as the structural design is concerned. That's a nice, naive way to look at things, but I think that it simply is not taking into account the huge number of peoples and companies that are involved in construction of design and construction of projects such as this, and the economic pressures that they are all under. Yes, it would be nice if they were perfect people, but they're not. So here are some, in my view, realities. First of all, the building design and construction process is highly complex. It's not only technically complex, it's organizationally complex. It involves many people with different capabilities, motivation levels, and economic objectives. Point number 2, I think that we've got to keep in mind. People always make mistakes. It's human nature to make mistakes. Any process where people are involved needs to recognize this. A third reality is that economic pressures are very powerful forces in the building design and construction industry. All of the members of the building design and construction team are under enormous economic pressures. Most, if not all, obtain their work through price competition, competitive bidding, either formal competitive bidding or informal, where a general contractor calls up 5 plumbing subcontractors, says, give me a price to do the plumbing on this building, and then he selects the lowest price. And it's axiomatic that someone cannot be held responsible for achieving an objective without commensurate authority. And we need to also recognize that although all members of the design and construction team do not have the same level of expertise, all do have some level of expertise. A mechanical engineer might have looked at these shop drawings and said, something looks funny here. Maybe we ought to take another look at this. Or a technician or a construction subcontractor. And so you need to have uh, certain realities in place, in my view, on a construction project. You need to have a clearly defined organizational structure, and you need to have clearly defined and enforced process procedures, and that you force as many sets of eyes as possible within this organizational structure and these procedures to at least look at the relevant documentation on a project, the drawings and specs and the change orders and the shop drawings and so on and so forth, because somebody may catch an error like this. And an approach that I am a big advocate of is on substantive design and construction projects is an independent constructability review. In other words, where you bring in a completely independent company or perhaps consortium team of individuals who have a high level of expertise at building design and construction to independently review the drawing specifications and shop drawings to look for constructability issues or safety issues. So an independent constructability review, I think, is a very important tool. Now, procedurally, then, the way that this is a simplified picture here, just using this particular project for illustration purposes. But these shop drawings that WRW prepared at Haven's instigation went directly from WRW to Gillum, the nominal structural engineer. They should have been sent through the admittedly more complex and time-consuming process of WRW in this illustration, submitting the shop drawings to Havens, requiring Havens to sign off as having reviewed the drawings, not approving them, but committing that Havens reviewed WRW's design. And then those same shop drawings should have gone to the general contractor, Eldridge, and Eldridge should have been, by the project procedures, required to sign off as having reviewed the drawings. The drawings then should have gone to the construction management firm, Concordia. What are they doing on this project? And Concordia should, by the project procedures, been required to sign off as having reviewed the drawings, the shop drawings, not approving them, but signing off as having reviewed them. Because by forcing all of these people to commit by their signatures that they have reviewed the drawings will hopefully motivate them to pay attention to the shop drawings, and maybe they will catch these errors like this. What about the owner and the Hyatt? Did Hyatt should have been required to review the drawings. Then they went from Hyatt and the owner to the master designer, the architect, PBNDML, and from the master designer, after having signed off as having reviewed them, they then go to Gillum. And hopefully, with this admittedly more circuitous and time-consuming and somewhat costly procedure, it hopefully someone along that line will take a look at these drawings, these shop drawings, and say, something doesn't look right here. We need to take another look at this. So that's kind of force as many sets of eyes as possible to look at the contract documents. Recognize that team members have different levels of expertise, but all have some level of expertise and therefore potentially can spot errors. The requirement for sign off at each level forces the team members to take things seriously and accept some level of responsibility. The owner's participation in this process is essential because only the owner has budget authority. And there are well-accepted methodologies where time is critical to issue directives with post facto sign-offs. So, and then the concept of the independent constructability review. Okay, to summarize, to prevent incidents like this in the future, force as many sets of eyes as possible to look at the drawings and specifications, force the team members to take things seriously by requiring sign off, and convince the owner to fund an independent constructability review. So that is, well, and the one positive aspect that, that did come out of this incident is that building departments across the country began to upgrade their drawing reviews when building permits are applied for. And this has been very constructive, and the evidence of that is that there have not been any incidents like this of this magnitude since this one. So that is the end of our time, and I hope you have found this a little bit interesting. It will allow you to think about this a little bit more on your projects as they come across your desk. And with that, I'll just thank you very much for letting me chat with you today. And now I'm just going to close things out. So have a nice rest of the day. Thanks a lot. Bye.